cavity, right? Okay, just see the core and cavity. See here, this is the component we have. Okay, and for this component I want to extract the core and cavity only. Is it clear? Please give me reply. Okay,
Yes, sir.
so what is the complexity into this component? If you see this component in a proper way, you can see that this is there is a restriction when you apply the core and cavity extraction into this component, right? What is the extra? What is the restriction for that? Because this is a simple parting line, right? But some feature are difficult, right? Into this component, you can see this. See here. See here. See, I'm talking about this section, right?
Yes, sir.
This is quite difficult, but how we can extract this portion from the core and cavity? See, just right now I'm preparing a core and cavity. I'm preparing just a sketch for core and cavity. That this is nothing but this is the size of the core and cavity. Okay, what size I'm taking here? I'm taking 15 from the edge of the component to the edge of the cavity or the core insert. Okay, so from this point to this point I am taking 15%. Why? What is the reason of that?
For feasibility.
Feasibility, right? Manufacturing feasibility, this is important. This 15 we should take, right? Minimum 15 we should take, right? Okay, so just I am extruding the, see what is this? This is nothing but this is the core. Okay, acha, how to select the core thickness here? Tell me, how to decide the thickness of the core? Cooling diameter, right?
Diameter.
Cooling
Yes,
diameter.
sir.
Okay, so cooling diameter is depending upon the wall thickness of the component, as I told you, right?
Yes,
Okay,
sir.
so what is the wall thickness here? Okay, let's
2 mm.
check the wall thickness. How much? Sorry,
1.5 something.
1.5 mm. Okay, so let me check again. 1 minute. From this point to this point, it is around 1 mm. 1 mm uniform wall thickness, right? Okay, so for the 1 mm 1 mm wall thickness, how much diameter I can take of the cooling pipe?
4 to 8.
4 to 8, right? So 0 to 2 mm I can take 4 to 8 mm. So for the 1 mm I should take 6 mm, right? But because of the
Yes.
manufacturing feasibility, I suggest that you should take 8 mm, right? Because 6 mm is difficult to manufacturing into the plate. That's why we are taking the 8 mm, right or wrong?
Yes, sir.
Understood? Okay, so I am taking 8 mm just for an example, right? Okay, so if I am taking the 8 mm, so this is the diameter. So from this point to this point, I will take 2 into A, and from this point to this point, I will take 2 into A. So it will become 32. So if I purchase the material from the market, right? So what size I can get from the market? Tell me. 30, 30 mm thickness, right?
Yes.
Okay, so this is the reason, that's why I am taking here 30 mm, right? So right now how much I have take? See here, I am taking 30 mm. Okay, see, this is the 30 mm. See, okay, understood?
Yes.
So this is the core thickness. Okay, now take the cavity thickness. How much the cavity thickness I can take? 1 minute. Here, see, so this is the 1 minute. See here, this is the feature here, right? See, 1 minute. This is the feature of the component which is difficult to manufacture, right? Okay, so for this we have to prepare a insert. We have to prepare a insert. Is it clear?
Yes, sir.
1 minute. Okay, so we have to, screen is visible?
Yes, sir. Yes, sir.
Yeah, so we have to prepare a insert. So insert will be like this. For example, the insert edge will be like this. See, this is the insert edge, right? Same edge will be the insert edge, right or wrong?
Yes.
Okay, so we have to extrude this insert from the bottom to this face. From the bottom to this face. Understood?
Yes.
Okay, so what is the reason that we are creating the insert here? What is the reason of that?
Because there is no. We should open that area, right?
Yeah, because this insert will become into the cavity side, right? And this local insert this local insert will match with this, with that face.
Correct.
Not understood? See,
Yes, sir.
just for example, I am taking the extrude command, right? See, this is the insert, and this insert will be added with the core plate, right?
Correct.
है ना? This will be unite with this core plate. अच्छा, लेकिन what is the reason for that? What is the reason for this?
Because we cannot manufacture with the cavity.
Yes. Okay. And this portion, this is the male portion, right? And female portion of this exist into the cavity side, right? Okay. Right now, just I am adding this portion with this, right? See. Okay. But here, if I am talking about this face, okay. So here should be a draft here, right? There should be a draft here. Here. Achha, why? What is the reason of that draft?
To easily remove the.
No, I'm taking the draft into this metal portion. See, for example, see here. See, this is the insert we have, right? And this has a 90 degree. How much? 90 degree. Okay. And another we have, this is the insert, and this also have a 90 degree. Understood? For example, if some reason there is a error in manufacturing of 0.1 mm, okay, so because of that 0.1 mm per side, it can be create a collapse between this face, right or wrong, because both are in 90.
Correct.
Okay, so basically it can be a reason of damage the core and cavity insert, right?
Yes.
Okay, so that's why we need a draft here. Okay, so draft will be like this. See, for example, this is the portion here like this, and this will be the portion here like this. 1 minute, sorry, not like this, right?
Yeah.
Yeah. So this will be the clearance always. Okay, this will be the clearance between them always. So basically, for the safety purpose, you can say that, right? Into the metal portion, we have to give the draft angle, right? Okay, so that's why I am splitting this portion. है ना? I am splitting this portion. See, here you can see that from this face. Right? See, I am splitting this portion, right? And I am just giving the draft. How much draft I am taking here? See, should be less than this face, right? Okay, so I am taking the 2 mm. 2 mm draft I am taking here, right? And draft start from which face? From which face? From this face here. From the upper face of the component. See?
Got it.
Okay? This is very important. Understood? Okay, so this draft is very important. So here you can see that our core is prepared. Core insert has been prepared. Right? Understood? See. Now, yeah. So here you can see that now I am 1 minute. Again unite this portion, uniting this insert with this complete. You can say that complete insert, right? So this is the one single part. Okay, I'm extruding cavity portion here. See, 1 minute. This is the nothing but this is the us. Right now this is the us a solid body. Okay, right now this is the solid body here. Okay, now you can see that 1 minute. This is the wireframe. See here. Okay, how much I can take? 50 mm. 50 mm. Is it clear?
Yes.
Okay. So just 1 minute. See. Understood? See. Okay. So just subtract this core from this upper block, which is the cavity portion, right? Subtract here. Okay. Or during the subtraction, you have to tick on keep tool. Okay. Why? What is the reason of that? What is the reason of that? We have to tick on keep tool on. What is the reason?
Which one is the tool, sir? Means it's a
This-
body or what?
This 1 minute. This will be the body here. This will be the target body,
Okay.
and this will be the tool body. Say this core will be the tool body. Okay.
Okay.
See, Okay, so see here, you can see that. 1 minute. Control J. I'm just removing the transparency. Okay, see here, you can see that. See, this is the impression here, right? Now you can see that here, this is the, see, this is the component, right? And here from this block I will subtract the component also. See, I am subtracting the component now. See, now use the control shift I and hide this portion. Okay, so control shift B for ball. See, now this portion will be the part of this core portion, right?
Yes.
Okay, now unite this portion. See, okay, this is the core, nothing but this is the core, and you can see that this is the cavity portion here. See, this is the draft into the insert, right? This is
Can you
very
show
important.
me again, sir?
Again, see, again, see here, right? This is the insert, right?
Yes.
Okay, now see here. Okay, again I am extruding the cavity. This is the cavity portion,
Yes.
right? See here. Okay, I am just subtracting the core portion from the cavity. Is it clear?
Yes.
Okay, see, subtracted, and see the, see, this is nothing but
Okay.
cavity, right? Now,
That cavity is ready.
yes, take the component from this portion and see here, and just I am subtracting the component from this side.
Okay.
Okay,
Okay.
okay, so subtract the component, see, and you will get this middle portion. See, just hide the center portion, and this is the center portion. See,
While you selecting the part, you going to delete or what you do?
now I am not deleting, I am just using the control shift I. Control shift I, it means basically if we know about the NX Unigraphics work in 2 layers, right? See, control shift B, right? This is the cavity, and control shift B again, B for ball. See,
Okay.
okay, so this is the 2 layer here, right?
Okay.
Control shift B, see, control shift B. So if I am hiding this portion, control shift using control shift I am just hiding this core portion. It means it will be here. Control shift B again, it will be in this layer.
Okay. Okay.
Okay, so control shift I again, I am hiding this the core center portion, and see, and I will unite with this core here, right? See, just uniting. See here, understood? So basically we have prepared what we have prepared here. We have prepared the core and cavity. See here now. This is the simple parting line. This is the simple parting line. You can say that this parting line is known as flat parting line. Okay, what is known as flat parting line? Understood?
Yes, sir.
Acha, where is another student?
Probably they are busy with other meeting.
Okay, it's okay. Okay, flat parting line. Acha, understood about this thing?
Yes, sir.
And this is very important thing. Draft is very important. Okay, so note down this simple thing is that if you are dealing with the metal core and cavity, if you are dealing with the component, so basically if you are designing the component, for example, you are designing the product, so draft is very important thing there, right? And if you are preparing the core and cavity and you are trying to match the metal surfaces, right? Then during the design you have to give the draft into the metal surface also. Is it clear?
Yes, sir.
Okay, so this is the core and cavity for the duster component. Understood?
Yes, sir.
Okay, so 1 minute. Okay, see, see, understood about this?
Yes, sir. Yes, sir.
Okay, so here this is nothing but this is the mold, multi-cavity mold. Okay, so right now so basically in today's session we will complete the mold based portion, okay, which is very important. Or in a single cavity mold design we have covered that time, right, for the soap case. Okay, so today I will cover in previous lecture what we have covered on Friday,
Flow line. Gate, runner and gate.
runner and the gate we have discussed, right? So you understood about the runner and the gate. Acha, let me ask one question about that. 1 minute. Tell me, acha, what is the formula for the runner diameter? Tell me. Right?
Yes.
It's very important, right? That's why I remember this thing, right? Okay. Acha, if I am taking the age gate, okay. Acha, on which three factor gate selection is dependent? Tell me. Tell me. Appearance, application, and fitment. Depending upon these three factor, we have to select the gate selection. है ना? Gate selection of the gate is depending upon these three factor. Is it clear? Okay. Now if I am talking about the parameters of edge gate. So what is the height of the edge gate? Tell me. L into T, right? Okay. And what is the width? 2 into H.
Okay.
Understood? Acha, what will be the L? 121.25 mm. Is it clear?
Okay.
Understood?
Yes, sir.
This is very important parameter. Okay. है ना? But for this, this is the component, right? But for this component, we will use the fan gate, right? Acha, why we are using fan gate for this component? Tell me. You have attended that lecture or not?
No, sir. Last class I missed.
Okay. So basically depending upon the geometry. Why? Because geometry, you can see that there is a ratio between the length and the width, right or wrong? You can see that if the length is around 30 mm, width is 30 mm, then you can see that length is about 60 mm here, right?
Yes.
Okay, so that's why, for example, if I'm using edge gate here, so what will happen here because of the edge gate? So there will be the flow of the material like this. Okay. Okay, so because of this flow, weld line will be produced here. Weld line will be produced. But if I will use the fan gate, so what is the fan gate? How it look? See, it will look like this. See, so fan gate will be like this. Understood? So because of this, you can see that because of this design or the fan gate, because of the fan gate, flow will be like this. It will spread the material.
Yeah.
You can say that equally uniformly into the component, right?
Yes.
Okay, so that's why we have to use the fan gate into this component. Okay. So that's the reason. That's why we have to choose the appropriate gate depending upon the component geometry as well as the depending upon the appearance, application, and the fitment of the component.
Okay.
Is it clear? Okay. So this is all the basic which we have covered. See, so this is the single cavity component right now, right? So we have to prepare the multi cavity mold. Okay. So customer says that customer has few condition. That sir, we have to this material. See here, I am talking about this component. Okay, so this component has a material PP, right? Customer has few condition, right? And a customer says that how much cavity they want? They want 2 cavity. How much?
2 cavities.
2 cavity. And a customer says that sir, we have a 80 ton machine. And we have a 50 ton and the 80 ton machine, right? So we have to prepare this component. We can prepare this component into the 50 ton or the 80 ton machine. Is it clear?
Yes.
This is the condition. Okay. And one more thing is that customer says that we need cold runner mold. What runner we need? They need cold runner mold. Cold runner. Okay. So cold runner, it means 2 cavity. Into the 2 cavity. Sorry, into the 2 cavity or the 2 plate mold. Is it clear?
Yes.
2 plate mold. Is it clear? Understood. Okay. And one more thing, customer, for example, right? So this is the simple thing is that, है ना? Simple thing. this is the condition of the customer, right? Customer says this requirement should be fulfilled from the mold. Is it clear?
Yes.
Okay, so here see, this is the component we have. Okay, customer says the PP is the material. So how much shrinkage I can take for this component? Tell me, for this material. What is the range for the PP? 1 to 2% for the PP material, right? Okay. Now, depending upon the dimension. For example, this is not a fitment component, right? Is this the fitment component or the critical? There is a critical feature into this component. This is which is required for the fitment for other component. Or is this the assembly component? Tell me. No, this is not the assembly component, right? है ना?
Yes.
So we can
Yes,
take
sir.
1% shrinkage, right? Rough shrinkage, you can say that. This is the household product, you can say that, right? Or the stationary product, right? Okay. So right now we have to, first of all, we have to prepare the multi-cavity layout. Okay. So move this component. See, this is the component. See, right? Okay. So from the center to the edge of the component, how much distance we should take?
15 mm. minimum.
15 mm again, right? So I can take, see, this is the distance, right? This is the distance. Okay. Now you can see that if you see the geometry of this component, you can see that this is the identical component. For example, if I am taking the mirror command for this component, we will get the same component here, right or wrong?
Correct.
Okay, so that's why I am taking the mirror. See, so from this component, from this point to this point, how much distance I am taking right now? See here. So you can see that. Nah, not 30 mm. I am taking more than 30, right? I am taking around 1 minute. 50 mm. Okay, so from this point to this will be the 25. From this point to this point, I am taking 25. Why? Because one more element, one more feature I will take between this feature, right? These two components. That's why I am taking the 25 and 25. Right? Because when I will complete the core and cavity for this, right, I will take one reference hole here. Okay, so from this component reference hole from or to this edge, there will be the distance about 15 mm. Is it clear?
Oh, okay.
Okay, so that's why I'm taking 25 and 25. Is it clear? Okay.
Yes.
So this is the two cavity here. Okay, you can see that. Okay, I'm taking the core and cavity. What I'm taking? Core and cavity. This is the sketch for the core and cavity insert. Okay, now you can see here. I'm taking what I'm taking here. I'm taking 30 mm and 30 mm distance from this face to this face. Why? What is the reason of that? So I should take the 15 mm, right or wrong?
Yes, sir. Yes, sir.
But I will add one more feature here, which is very important. And note down that I will add a feature here, which is nothing but the interlock.
Okay.
Okay. And what is the purpose of the interlock? Why we are designing the interlock? Interlock.
Lock.
Yeah. Interlock will provide the center alignment to the core and cavity.
Okay.
So interlock is just like a guide pillar and the guide bush, you can say that. But interlock I am using here for the center lining of core and cavity inside. Now if I am talking about the guide pillar and the guide bush, the guide pillar and the guide bush is used for the alignment of complete mold, right?
Okay.
Okay. So that's why I am taking 30 and 30 mm here. Okay. Now see here. Okay. Okay. Just create again. What is this? Core, right? Same as like single cavity with core and cavity inside we have created just now, right? See here.
Yes.
Okay, and again 1 minute. See, this is nothing but this is the interlock. Okay, what is the dimension for the interlock? I have taken the 25 and the 25, right?
Yes.
Right now 25 and 25. And here you can see that from this point to this point it is around 10 mm distance only. But I will take the radius for this, right? Okay, so there is no issue about that. See here, this is the interlock. See,
Okay.
interlock, है ना, which is about 15 length, right? See, I will give the draft here, है ना, how much I can draft. For the interlock, we should take the 10 to 15 degree draft always, okay?
Okay.
For the interlock, how much draft I should take? Always 10 to 15 degree. Is it clear?
Yes.
Okay. See, so as I told you, this is the metal. Okay, so this is the female portion, and if I'm talking about the sorry, this is the male portion. Okay, or female portion will be on cavity side, right?
Cavity side.
Right. See here. Understood? Okay, just take the edge blend. Okay, I am taking the edge around 6 See here. Okay, just take the edge blend in this section. See,
Yes.
है ना? See. Okay, take the mirror. Okay, understood? Just unite with this.
Okay.
Okay. See, just prepare this cavity section. Okay, so 25 plus 32, so I can take here around 60 okay,
Okay.
60 and click OK. See, okay, just subtract the core portion from the cavity inside.
Cavity.
Okay, subtract. See here, so this will become the,
Okay.
understood? Now,
Yes.
for the manufacturing aspect, I have given the radius here, right?
Yes.
I have given the radius here, but here in this section you can see that this radius is not necessary here, right or wrong?
Yes. Yes.
Not necessary. So that's why I can delete this radius here from here, right?
Okay.
Okay, see. Right now I am deleting. See, because face to face matching should
Yeah,
be
yes.
there, right? So that's why I am deleting this portion. Is it clear?
Yes, sir.
Understood. Okay. See, here you can see that. See,
Yeah.
it will be like this. Okay.
Okay.
And here I have take the radius at the outer edge also. Is it clear?
Yes.
Okay. So you understood about this. So basically I have created the core inside right now and the cavity inside right now. Okay. And even I have not prepared the impression of the component into the core and cavity yet, right?
Yes.
Okay. See here. So basically we are preparing the core and cavity, sorry, mold, you can say that complete mold base right now, okay? Which is very important for the multi-cavity mold, okay? Now see, this is nothing but this is the housing here. Okay, this is the sketch for the housing. Now this housing is depending upon the tie bar distance of the molding machine. Is it clear?
Yes, sir.
Okay, so right now I am taking the extrude command. See, this is for the core and this will for the cavity portion. Is it clear? Okay,
Yes.
how much I should take? This is the 75 and this will be the 60. So here I am taking the 61. How much?
61.
61. Why I am taking the 61?
That way shouldn't affect with the
Yes.
current cavity.
Yes, so this will be the 1 offset from this side.
Yes.
See, and again for this cavity side I am taking this 76.
6.
है ना 76 and this will be the 1 offset
Offset.
है ना and click OK. See, so control H. See, so there should be a clearance between them.
Yes.
Understood?
Yes.
Okay. है ना, this is very basic thing. You understood about this? This is the meeting point right here.
Okay.
Okay.
Sir, once again.
Yes.
Are you getting any background sounds from my side?
Sorry.
Are you feel any background sound? Are you getting means?
From your side?
Yes, sir. Yes, sir.
No, there is no.
Okay.
Okay. So understood about this thing? So we have prepared the core and cavity housing right now. Is it clear?
Yes.
Okay.
Yes.
Just I'm 1 minute. I'm extruding this portion. See, I'm extruding this portion. Okay. See. So see here, right? Understood?
Yes.
Okay. And again for this section you can see that this is the housing insert, right? Housing and the insert. Okay. Okay. Now here So I am taking the offset, so I am removing these two things, right? Because I have already taken the offset here, right? See, again, see, what is this? Tell me, because we are discussing the mold base right now for the multi cavity. What is this?
Back plate.
Top plate, because this is on the cavity side, right? See, this is the top plate, right? And now for the top plate I have taken the 30 mm. Okay, understood? See, what is this? This is the clamping area, right? Okay, I am taking the sketch for what?
Spacer.
Yes, spacer. Okay, so how to decide the spacer distance? Tell me. Or the height of the spacer?
Type or diameter.
Yeah.
Type or diameter.
Okay, but if I am talking about the this dimension, which is the width,
Yes, sir.
so basically this edge should be far from the component edge, right?
Correct.
Okay, so I am taking the 50. Even I can take the 60 or the 65, but minimum I should take here, right? Okay,
Okay.
so this is the spacer dimension. So here I am extruding this portion. See here. Okay, how much? Component height, component height is about 30 mm. Okay, so 30
Yes.
plus 10 mm will be the clearance, 12 mm for the ejector plate, 17 mm for the ejector back plate, 5 mm for the rest button.
Okay.
Okay, so you will get the height of the
Spacer.
spacer, right? This is nothing but this is the bottom plate, है ना? Which will be same as the top plate,
Top plate.
right?
Yeah.
See, okay, and last one we have to create the ejector grid. See, this is the ejector
Correct.
grid. Okay,
Yes.
so what we have completed here, we are completing the mold base. We are preparing the mold base right now, right?
Yes.
Okay, understood about this thing?
Yes, sir.
See, okay,
These are we
so
already did.
yes, okay, so this is the moving half here, and this is nothing but this is the fixed half.
Fixed up.
Fixed half, this will be the moving half.
Moving
Understood? Okay, now see. Okay, 1 minute. Okay, acha, what is this? Tell me. This is the very basic things. Okay,
Reference.
I will all these basic things I will create in say multi cavity mold, because in upcoming mold that mold will maybe they will be critical. Okay, depending upon the component geometry. Is it clear?
Yes.
Or the complexity. So all the basic element I will cover in the multi cavity mold. Is it clear? Okay. What is this?
Reference cut.
No, this is not the reference cut. Basically, it is for the tooling purpose. For example, if you want to detach or the dismantle this two portion, right? And sometime we have to give this type of cuts. So basically, this cut will help the open two plates, right?
Okay.
Okay, that's why. So this is not the reference cut. You can say that. Understood? Okay.
Okay.
So right now I am taking the. Acha, we have covered the. We have discussed about the bolt calculation.
Probably not it.
I think we have covered about the bolt calculation in single cavity mold.
Mold calculation.
Bolt
Yes, sir.
calculation, bolt selection and the calculation.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
है ना? Yes. So I am taking the bolt for this. Okay. See. Okay. For the bolt for this insert, right?
Yes.
Okay. Just take the bolt. Okay. See, it will be like this. See. Right?
Okay.
Understood? See?
Yes.
See. I am taking this gauge. 1 minute. See. Now, one more basic element, basic component. You can say that. Tell me, what is the purpose of this? Tell me. This one. I am taking this. Okay. This is nothing but this is the wear plate. You can say that. This is the wear plate. Okay, just I'm designing the wear plate. This is nothing but this is the rectangular box, you can say that, and a rectangular component.
Box.
Okay,
Okay.
see. Okay, and it's you can say that its thickness or the face will be matched with this face. है ना?
Uh-huh.
What is the reason of that? See, for example, this type of rectangular section we will use here. See, we will use here, we will use here, we will use here, and here. And now tell me, what is the use of this? Tell me. Because if I'm talking about the injection molding machine, basically injection molding machine apply the force on this face, right or wrong?
Yes, sir.
On the core and cavity, but it will also apply the force on this area also, right or wrong?
Correct, correct.
Right. So because of that, for the force distribution, we have to use this type of plates.
Okay.
Okay. Okay, otherwise, for example, if we are not using this type of plates or the support, you can say that, so because our housing will be touched with each other, right or wrong? Sometime we can say that after the 1,000 shot or the 2,000 shot, our housing will be made to each other, right or wrong? So
Yes,
that's
sir.
why this block is very important. This is also known as wear plates.
Got it.
Understood?
Yes.
So this is very basic element. We have to use this one, right? Okay, just I'm using this is, see, this is the, okay, and what is this? This is the relief hole for that. है ना? This is the relief hole for that. Okay, and just use the screw for this. See, I am taking the 2 screw. है ना? So as I design at this point, you have to design this type of wear plate at this point and at this point also, right? Right? Understood? Understood?